Hello, my name is Brendan Hyde.
I'm Clay Dodge.
And I'm Brian Toto. And this is our ME435 final project. In modern times, manufacturing facilities have been utilizing robot arms in their production lines. The benefits of robot arms include high production speeds, reduced labor costs, workplace safety, and the ability to work without breaks. For these reasons, it is likely that manufacturers will continue to implement robot arms in their facilities in the future.
Penn State's Mechanical Engineering Systems Lab provides the resources for students to gain hands-on experience with robotics. Students were tasked with programming a robot arm to execute various tasks, including identifying color and shape, using a conveyor belt, using different end effector types, and placing an identified shape in a specific location. Through 3 different labs, our team has also learned how to integrate a camera into the robot system itself.
The video clips shown are examples of the different labs we've completed throughout this semester. In this specific video, the Dobot is picking up the red blocks and moving them to a specified location. Another example of what we've done in our labs is communicating with another Dobot. In this example, another team's Dobot picks up a block, moves it to a location within the range of our robot, and then sends a signal to ours. Once we receive the signal, we can pick up that block and place it on a location within the range of our robot.
In order to use the images taken with the camera, a precise end effector was utilized to sync the coordinates of the robot arm with the coordinates of the images using a 9-point calibration.
In this example, we use the camera to calculate the difference in angle between the piece and the slot. We then compensated for this difference during the movement of the piece to ensure the correct orientation during placement. Now that we have completed all the lab testing, we then moved on to our final project. The initial tests found that the robot had trouble distinguishing between the letters that can fit into each other. For this reason, we ended up changing the word from car to bus in later tests to make the letter recognition less complex.
Another issue that we encountered were the inputs of the scripts that interpret the angles of both the letters and the slots being incorrect. This resulted in the letters not being rotated to the correct position while being moved. Thankfully, we were able to resolve the issue by troubleshooting the block diagram.
Our final task was to find the specific letters of a puzzle and then place them into their respective locations. This involved sorting the letters by both color and shape and passing them to another robot. Once the letters were placed, we then sent a signal to the puzzle robot to move the 3 letters into their spots. Both processes use a webcam and image processing to create coordinates of where the right letters are and where they are supposed to go. This combined all of the lessons learned in the previous labs into one fluid task. This first video shows us receiving the pieces and placing them into the puzzle. The next clip will show us giving the pieces of another group's pig puzzle.
When receiving the letters, the emphasis is placed on being positionally precise. On the other hand, for passing the letters over to the other team, the difficulty comes from finding the correct colors amongst the letters in the pile.
This final project taught us the methods used to command robot arms and how they can be integrated into actual work. The project served as a culmination of what we have learned in the ME435 class as a whole. This also reinforced the topics that we have been learning as engineering students at Penn State, such as troubleshooting, logical programming, and strengthening the connection between knowledge and real-world skills.